Now for the obvious question of what to do with this information now that we have it. This information is to be used to verify the frequency shifting behavior of the device. It does not necessarily inform us of the intensity of the lowered information. For the nonlinear frequency compression devices, as currently implemented by Phonak, it is okay to infer audibility from the aided speech spectrum, since there is a one-to-one relationship between the input frequencies and the output frequencies. For the frequency transposition devices as currently implemented by Widex, inferences about intensity are less certain because the frequency lowering behavior for a spectrally varying signal like speech depends upon where the spectral peak of the input signal is, and because the lowered information is superimposed with the original signal at lower frequencies, so that the observed output could actually be a mixture of the two. Also, for those of you doing research with these devices, hopefully you will appreciate how useful this information can be. Having a recorded file on hand for each subject can be useful when going back through the data and trying to explain useful trends and any unusual behavior in terms of perception and/or production. Back to the use of this information in the clinic. The information obtained by this technique can serve as a tool for selecting an appropriate frequency lowering setting. Minimally, we can use the information to avoid at least two important mistakes. The first is when the start of the frequency lowering is so high in frequency that none of the lowered information is audible. In this case, it should be obvious that a more aggressive setting should be selected if any benefit is to be expected. The other mistake to avoid is to have frequency lowering so aggressive that the bandwidth of the output is too restrictive compared to the user's audible bandwidth. In this case, a less aggressive setting should be selected in order to minimize undesirable side effects associated with frequency lowering. As an example, here's the aided speech spectrum for a moderately severe hearing loss with no frequency lowering activated. The crosshairs indicate that we are capable of achieving audibility out to around 3100 Hz. A reasonable expectation is that we can achieve the same level of audibility after frequency lowering. Here's the same hearing aid with frequency lowering activated with two different settings. The green is with no frequency lowering and is the same as the previous slide. The pink indicates a good match between the audible spectra before and after frequency lowering. The orange indicates a setting that might be too aggressive and that the output bandwidth after lowering does not take sufficient advantage of the audible bandwidth. Finally, I want to thank you for your attention and give you links to where you can obtain more information and links to where you can obtain the test signal and software demonstrated in this presentation.